Hello, everyone. I'm Albert Presto from Carnegie Mellon University, and I'm going to talk about our project, which is entitled VOC Sensors for ppb-level Detection and Speciation. Here's a picture of the project team. We don't have a picture of everyone together, unfortunately, because of complications due to the pandemic. And also because of the pandemic, and because, as you'll see in a second, this project is mostly laboratory based, we actually had some big changes in the composition of the team over the course of the project so far. So when the project started, the two undergraduates working on it were Shefali Karudi and Crystal Suero. They're shown on the left, and they were working with Jiayu Li, who was at the time was a postdoc in my group. And then we had that big break from the pandemic. Our lab was closed for a long while. In that meantime, Crystal graduated, Jiayu got a faculty job, and so we had to sort of adjust the team once we were able to get back into the lab. And so now we have some new undergraduate members of the team. They're shown on the right, Sophia, Max, and Sebastian, who've all joined recently, and they're all working now with Tofig, who's shown in the middle, in the bottom row. This project is about measuring volatile organic compounds. So volatile organic compounds, or VOCs, can impact human health, and they can impact the environment. A canonical example of a harmful VOC is benzene, which is carcinogenic, and benzene is present both in indoor and outdoor environments, and in products and emissions that happen both indoors and outdoors. We have a lot of laboratory methods for quantifying these VOCs. However, those tend to be bulky and expensive, and they're not necessarily well suited to, doing exposure studies or in-home interventions or anything where you would need something small and portable and perhaps low cost. And so our project is really about developing lower cost methods to quantify these VOC exposures. The way we intend to do that is to put together a VOC sensor suite, starting first with multiple commercial sensors. So we're starting with off-the-shelf sensors and packaging them together, and then hoping that because these different sensors have different operating principles, they have different sensitivities and selectivities. And then once we have some of that calibration data, essentially, we can build an algorithm to interpret the data from these multiple sensors, and then we would want to deploy them in various indoor and outdoor environments. Here's a picture of our current sensor prototype. And actually, mostly what you can see in this photograph is the data acquisition system. But the sensor suite itself is inside the white box. And so that shows, I think, 5 or 6 sensors that are attached to a breadboard. And then they're also connected to that lab jack for the data acquisition. What we've been able to do so far is laboratory testing of these sensor packages. So here's a picture of Tofig. Doing some calibration experiments. The sensor package itself is again inside that white box, which is now, that's a picture of it inside of a temperature controlled enclosure. And he's making parallel measurements with reference measurements, right? So we're able to relate sensor response to true concentration. And here's an example for just one of the sensors in the suite that we're testing. This is a response of one particular sensor to toluene. And we can see that, even at relatively low concentrations of a few ppb, we are getting some signal response. Maybe it's a little bit noisy, but we're getting some response from the low-cost sensor. And so we're making a big push on this in the summer now that students have a little bit more time. The semester was quite busy. But our next steps are to sort of come down and pick our final selection of the sensors and package them together, and then deploy them in homes and businesses around Pittsburgh. Thank you for your attention.